Good morning, this is your Stat Sensei, Mr. Spensei, and this is one sample proportions day one, and we are going to be looking at an exit ticket, okay? We've already had our lesson and we've noted the important information, but I'm still going to hand it out again because it's good practice. It says there are more than 161 million registered voters. That to me sounds like the population size. 2 months before the election and the campaign for president of the United States, polling indicated that 54%. All right, we now know from our lesson that that is our P, and that's actually our P naught. That's the claim. They favored the new candidate over the incumbent. However, the new candidate made several unfortunate remarks 3 weeks prior to the election. One week before the election, a random sample of 1,263 voters. All right, so we know it's a random sample, so that takes care of a condition. And we know that our sample size is 1,263. And then we show that 634 voters, and we know that that is our X value. And we're going to need that X value to find our P hat, because remember, P hat equals X over N. And that P hat represents our sample proportion, whereas P naught is our population proportion. Does the data support the conclusion that there was a decrease? So our HA is going to be a less than, or actually it's going to be like this. HA P is less than 0.54. P, not P hat, but P, excuse me. All right, so does the hypothesis, does the data support the conclusion that there was a decrease? And we're testing at the 1% level. All right, so let's look at this first part. Does the data hypothesis test indicate that there's a decrease? Well, our null hypothesis was that it equals 54% or equaled 0.54. Don't forget, you can always divide by 100. And the alternative was, is it less than 0.54? And these P's don't have to have a zero on there, but if it helps you out, to keep in mind zero for null or not. So when we ran the test, we believe the new candidate lost support because we rejected the null. That's what we did in favor of the alternative, which was that the support was less than the original 54%. So does your hypothesis indicate it? The answer is yes. All right, and that's what we came up with when we ran our tests in our notes. And you need the full explanation. The next thing, do the results from your hypothesis test indicate the new candidate will lose the election? Justify your response. And the answer is no. We just said that it'd be less than 54%. He still might have more than 50%. So the results do not indicate that the new candidate will lose the election. We tested whether support was less than 54%, not whether the candidate had less than 50%. So it's possible that we don't know this, but the candidate has somewhere between 50 and 50, or 50 to 54%. It's possible that his support lies in that range. And if it does, he's going to win the election. But we just said that no, we know it's not higher than 54%. It was 54%, but he lost some support because he said stupid things. Not that a politician would ever do that. The next thing, does your confidence interval indicate that the new candidate will win or lose the election? Justify your response, making certain to include the percentage necessary to win the election. Well, to win the election, they have to have greater than 50%. So, based on the interval, we do not know. This is super important. We do not know whether the new candidate will win or lose the election because our interval of 0.7145 to 53 contains 50%. The candidate could lose with as little as about 47.1%, or may win with as much as 53.2% of the vote. We don't know. All right. So because it contained the 50% and was not higher than 50%, we have no way of knowing. All right. If it hadn't contained, if it had started at 50% and went up, yeah, he would have won. If it stopped at 50%, they would have lost. But because it contains it and actually goes below it and above it, we don't have a way of knowing. All right. Appreciate you watching and I look forward to seeing you on the next one. Thank you.